So hello everyone, welcome to this new video. So in my previous videos, we have discussed with the two important examples under finite state machine model. So those two examples are very important, guys. So that video is very important. So please, those who have not watched that video, please go and watch it because those two examples of FSM model are very important ones. Okay, so it will be coming for the exam for sure. Okay, any one of them would be definitely arriving. So please, those who have not watched it, go and watch that video and like that video and comment down your opinions about how you understood that video. Okay. So in this video, again, we are going to continue with some concepts which are pending in module 3. That is in the computational models. We have few other models which are left, which are not so important. Just I'm going to read it to you all. Very easy ones. So the next type is sequential program model. Okay. In the sequential program model, the functions or processing requirements are executed in sequence. Okay, in this sequential program, the order it will be following a particular order of operations. Okay, so here we don't have any states or transitions. Here, if you take an examples of the seat belt warning system which I've discussed, in that also you are doing going to do this in a sequence manner. Okay, let us see. It is same as the conventional procedural programming. Here the program instructions are iterated and executed conditionally and the data gets transferred through a series of operations. Okay. So finite state machines, that is FSMs, and flowcharts are used for modeling this sequential program. The FSM approach represents the states, events, transitions, and actions, whereas the flowchart models only models the execution flow. Okay, so the execution of functions in a sequential program model for the seat belt warning system is illustrated below. So let us take an example again of the seat belt warning system only under the sequential program model. Okay, you see here, first to define the variables on, wait a minute. So here we have defined one is on, one is off, that is on is equal to 1 and off is equal to 0. Then define yes. So we have two conditions, yes and no. So define them. Yes, if it is yes, then 1. If it is no, then 0. Then open the loop, that is void seat belt warn. Then wait for 10 seconds. Okay, according to the condition of requirement of seat belt warning, you should be waiting for 10 seconds. If check ignition key is on, under that, if check seatbelt is off, then seat timer 5 seconds. That is if seatbelt is not there after the ignition key is on, then the set timer would be equal to 5 seconds. Start LRAM. That is LRAM would be turning on for 5 seconds. While check seatbelt equal to off and check ignition key is on and time expire is no. So these are the three conditions. Then you should be stopping the LRAM. That is, if seatbelt is off and ignition key is on and timer expire is no, then these three conditions we have discussed already in that finite state model also. The same thing we are writing it here. Then the LRAM would be getting stopped, then close the thing, and this is the complete sequential program model. Okay, written in terms of program. So this is the program model you see here for seatbelt warning system, the flow chart. First ignition key on, wait for 10 seconds. Okay, if ignition key on, then if it is yes, then seat belt is on. Again, if seat belt is not put, that is see they have mentioned here is the y and n. So this is y and this is n. So seat belt on. If the seat belt is not on, then set timer for 5 seconds, start LRAM. Okay, then again if ignition on, no, then again ignition on. You see here, if the seat belt is not on, the set timer for 5 seconds, but if the seat belt is on, end. Okay, similarly if ignition on, the seat belt on, but if ignition key is not on, end. Okay, so like this the flow goes on. Then after that, set timer for 5 seconds, start LRAM. If ignition key on, so ignition key is not on, then again you should be oning the ignition key first. But if it is on, then the seat belt should be on. But if the seat belt is not on, the timer would be getting expired. Okay, if the timer is not expired, then you should be oning the ignition key, and this is the complete loop which is getting followed. And this is the complete flow chart of the sequential program model. Okay, just go through it each step by step very carefully, and you will be understanding it. Okay, so this was about the sequential program model. Next we have concurrent or the communicating process model. Okay, so this is not so important, but still I'm going to read it to you all. The concurrent or communicating process model models concurrently executing tasks. It is easier to implement certain requirements in concurrent processing model than the conventional sequential execution. That is, the sequential execution leads to a single sequential execution of task and thereby leads to a poor processor utilization. When the task involves input output waiting, sleeping for specified duration, etc., if the task is split into multiple subtasks, it is possible to tackle the CPU usage effectively by switching the task execution when the subtask under execution goes to a wait or sleep mode. Okay. However, the concurrent processing model requires additional overheads in task scheduling. So the scheduling the task in this communicating process model is very important. Okay, you have to schedule the task, because if the task scheduling is not done properly, the process model won't be working properly. Okay, task scheduling is required. Task synchronization, that is the tasks which you have scheduled, right, those should be having a sync between one and other steps. It should be of a sequential order, and the communication between each task should be properly executed. As an example, consider the implementation of the same, that is seatbelt warning system, using concurrent processing model. So here we can split the tasks here. That is, the tasks are timer task for waiting 10 seconds, that is wait timer tasks. Task for checking the ignition key status, that is ignition key status in monitoring task. Then task for checking the seat belt status, that is seat belt status monitoring task. Then task for starting and stopping the alarm, that is alarm control task. Then alarm timer task for waiting 5 seconds. Okay, so these are the, in this processing model, concurrent processing model, the each states and transitions are divided into tasks. Okay, that is the different tasks are mentioned here. According to that, this is the complete status here for each task. Okay, for each task separately they have mentioned the programs here. Okay, just go through it and you would be understanding it. Okay, and how these things are interlinked in the diagram they have neatly mentioned here. Go through each task, read these starts read these stats which is mentioned in each box, and try to understand it. Okay, I'm not going to read it, so please understand it. If you read it, you will going to understand it. Okay, so this PDF I'm going to put it in the description. So this is not mine. This is provided by the VTU developer site. Okay, so shout out to them. And this notes is very neatly provided. Each and every concepts are mentioned very neatly. So please go and access it from the description and read it. Okay. So we have one more kind of model which is penned, that is object oriented model. Okay. The object-oriented model is an object-based model for modeling system requirements. It disseminates a complex software requirements into a simple, well-defined pieces called objects. Okay, in this object-oriented, the whatever the model is required, that is based on the requirement of the objects here. Okay, the object-oriented model brings reusability, maintainability, productivity in system design. In the object-oriented modeling, object is an entity used for representing or modeling a particular piece of the system. Each object is characterized by a set of unique behavior and state. A class as an abstract description of a set of objects. It can be considered as a blueprint of an object. Okay, a class represents the state of an object. So this is the definition of a class in this object oriented model. This represents the state of an object through member variables and object behavior through member functions. The member variables and member functions of a class can be private, public, or protected. Okay, so the private member variables and functions are accessible only within the class, whereas the public variables and functions are accessible within the class as well as outside the class. Okay, the protected variables and functions are protected from external access. However, the classes derived from the parent class can also access the protected member functions and variables. Okay, so if you read this once, you will be easily understanding it. Okay, so this was about the object oriented model. So in this video, we have discussed three important models which were pending. That is a sequential model. Then we have concurrent process model and the object oriented model. Okay, so these three models are not so important, but it was pending, so that's why I thought to do this video. So I didn't take much time. So if you want to read this in detail, this notes only I'm going to provide in the description. Please go and access it and read it. Okay, so that's all for the video, guys. Like, share, subscribe to our channel. Keep supporting. Thank you.